All right. What is up, everybody? Tom McGurl here with another episode of Learn Rust Live. We're continuing with the exorcism Rust track. So we're going through and doing some Rust exercises. We'll check that out in just a second. If you're on the stream tonight, feel free to use the chat to send messages, talk. We can interact a little bit. Ooh, I forgot to put my sign on. There we go. We're hacking. We're hacking now, so gotta have it on. Yeah, so thank you for joining. If this is your first time, that's great. Welcome. We have the Twitter. Check it out. The plugs. We're doing the plugs, right? Follow here for if you want updates for when I go live. If you missed the videos before, what we're doing is we're picking up on the exorcism track. So we have 4 videos out so far. We put the last one up last week. I started the stream again. If you're not watching live, if you're watching on YouTube, you can always join us live on twitch.tv/TomandGirl. You can see it up there in the top, right? 9 to 11 p.m. usually. Sometimes we'll go a little shorter, just depending on how much we want to get done. But yeah, hop in the live stream so you can chat with us. You'll notice in some of the videos I'm chatting with the chat. It's fun, it's interactive, it's cool. But if you're on YouTube, thank you so much. It's been really awesome to see all the views. Obviously, a classic plug, right? Hit the subscribe and like button. But I gotta say it. Like I said, I joke, but I mean it, right? Do it. It's fun. It lets me know that you're interested. But yeah, leave comments. Feel free to contribute through that. I had some really great comments, some really good ideas for stuff I can do next. So a lot more content coming up. But today's all about exorcism. This is part 5. So here's where we're at with exorcism. We're doing the Rust track, and it's fantastic. Again, if this is the first time seeing exorcism, highly recommend. It's very cool. Somebody asked in the chat if there's a dark mode for this website. Not that I know of right now, but it's open source, so they accept contributions. So maybe we contribute a dark theme. It seems like a big lift, but maybe it could be cool. If not, you can always get the Chrome extension that will force dark mode. So I'm going to show you all how to do that right now really quick. So basically what you do is you go to Chrome/flags, go over to experiments, make sure experiments is on, right? And then if you look, you do a search for dark, you'll find auto dark mode for web content. Just set that to enabled. You're gonna have to relaunch the browser, no big deal, relaunch it. But you'll see it forces some of those pages into dark mode. If the pages already have dark mode, it'll use it, like Twitter here. But see, we get like a little free dark mode here. It's not perfect, right? Because it's just kind of flipping the contrast on websites that don't support it, but it's pretty cool. I'm going to go back though and turn it back on to the default, only because I like to see the way it's designed. I think the exorcism website's design is beautiful, so I want to maintain that. So what up, Doze Boy in the chat? Doze is my buddy. We've been coding together. We'll probably code together a little bit after this. Thank you for joining. And yeah, so let's take a look at where we're at. So we've been going through the syllabus, and now I talked about this last time. It's amazing. They've expanded the syllabus like literally since we started doing this, which is really cool. I mean, awesome to see how much movement and changes exorcism has been going through. So before, we just had some basic courses here, but now you can see they've added follow-up steps. So you can go wide, right? Like we're going wide. We're going to capture everything, but then we can go deep into these topics. So first, what we're going to do is we're going to continue our little path here. We're going to start with entry API. It's about using a hash map and the entry API of a hash map to solve some problems. And then if we have time, we'll do vector as stack, which is using a vector. So the VEC exclamation point, the vectors that we've been using that to simulate a stack with pushing and popping. So it should be pretty cool. Let's go ahead. I don't want to say let's jump right in because I've already spent like 2 minutes pitching Twitch and Twitter and everything to you. So all right, let's see what it's all about. So Rust's entry API provides a view into a single entry in a map, which may either be a hash map or a B tree map. Okay, I think we're going to deal with hash map. Yeah, so we're going to be dealing with hash map. B tree map is a binary tree map. We'll get into that later. The entry may either be occupied or vacant, and the API provides methods to modify the contents of an entry. Now, for those of you not familiar with the hash map, you can go, and you could always go look at the previous chapter where we took a look at this. I think we did that maybe in, I one of these chapters. I'll have to go through and like label them better, but we did cover that in the book. But to give a quick rundown, what we're going to use a hash map for is just like you would use, if you're familiar with JavaScript or Python, a map or like an object, right? So you have a key and a value, and looking something up by that key is usually order one runtime, right? It's single. You access it by the index. You don't have to scan the whole map. You know the key. So if you have the key, you can get the value. And so that's what we're going to be doing. So a hash map is a key value. So it's great for when you're storing stuff or information for a given key. Let's say, for example, like a lookup table, right? So you have the person's name and you want to get their information, or maybe use their ID. And so the ID is the key and the value is the information. Awesome. Dozeboy said, yo, I'll code along on some Rust with you. Let's go. Awesome. All right, so let's check this out. Look at how cool. Like, I just want to give a shout out. I'm going to have to, well, A, we're going to donate 100%. We've been using it, making content with it. Got to donate. Gotta. You have to. Just not you. I'm going to do it. Don't worry. You can too, though. You should. But I will definitely be donating because I've been getting so much value out of it. So got to do it. But I want to give a shout out to the artwork. I've been loving seeing like the artwork that they put out here. Like, look at the design of this site. It's beautiful. But each exercise is its own little artwork. So whoever's doing that, and I'll find out, and I'll give you a shout out on stream because that's awesome. Love it. But anyway, magazine cutout. So as usual, what we're going to do is we're working locally. So we're going to clone this. So we're going to pop over to our thing here, paste that to clone the magazine cutout exercise. It's going to copy it, and we can go into here. Now we have magazine cutout. And we'll go ahead and we'll open that up. This is just installing the update. Yours won't probably do all that. That's just because I'm on Windows Subsystem Linux. Oh, wait, look, what's happening? Let's do this. Let's just open it up in Explorer really quick. So I'm just opening up here because for some reason my my VS Code isn't wanting to open. All right, let's just open VS Code manually and then we'll point to it. No big deal. That's weird. All right, so let's pull this over here. So we have our previous exercise there. So I'm just gonna do File, Open Folder. And magazine cutout is what we want. Perfect. All right, so let's go back here. All right, so let's read a little bit about it before we jump in. Now we can read it. The instructions are actually also contained here. So if you want to see the instructions, you can use the README. And we could even preview it in VS Code. You could do preview to the side, like that. And it'll show you, but I like the website just does a really nice job of displaying it. So let's go over here first. All right. Why is it zooming? That's interesting. Okay, there we go. All right, so instructions. In this exercise, you'll be using a hash map along with the entry API method. So we'll have to take a look at those. I'm not familiar with those. To solve a simple algorithm problem. Given A, this is a reference to a vector of string slices. Doze in the chat says, I got to do the Rust track. I have to do the hello world to unlock these. He's going to listen and catch up. Awesome. Yeah. Go through the episodes 1, 2, 3, and 4. They're here. We go through them. But yeah, you have to do a few. It's a pass. You might have to do a few to unlock these. So we're going to have a reference to a vector of string slices. You remember string slices just represent pieces of strings. So it's a little different than an actual big, capital S string, right? And we cover that in the book. Representing the words of a magazine article. So we have an array representing the words of a magazine article. And we also have a reference to a vector of strings representing the words of a note we would like to send. Can you compose a note by cutting words out of the magazine and pasting them to a letter? I think we're building a ransom letter. You know what I'm talking about though, right? You've seen the mysteries where they do the ransom letters where it's like each letter is cut out from a magazine. So that's what we're doing, but we're not ransoming anything. Well, relax. We're making a note. Basically, we have a list, a vector of strings, right? So an array or a list, a vector in this case, of all the words in a magazine. So let's say the magazine just said hello world, welcome to Tom McGurl stream. Each of those would be in that list. Hello world, welcome to Tom McGurl stream. And let's say you wanted to make a note that just said hello stream. You can do that using the words in the vector. So basically, we want to be able to see if that's possible, and our code should be able to determine if that's possible. So you can see here, notes. This implies physically cutting and pasting. The magazine needs to contain at least as many copies of each word as the note requires. So in my example, hello world, welcome to Tom McGurl stream, you couldn't do hello stream stream. Hello stream stream, because there's only one instance of stream. This is saying there has to be, however many you need, there has to be that many available to be able to use it. Capitalization matters. Just because you're pasting together a note composed from words of a magazine doesn't mean you're willing to be ungrammatical or grammatically incorrect, right? Okay, interesting. We'll see how that comes into play. You'll start with the following stubbed function signature. So we have this basic function signature called can_construct_note. It takes the magazine, which is a vector of string slices, and the note, which is also a vector of string slices, and it should return a bool, true or false. Can the note be constructed? So given the following input, let's take a look here. So the magazine is 2 times 3 is not 4. No, that's because 2 times 3 is 6. So 2 times 3 is not 4. And so what they're doing is splitting by the white space. So that gives us each word. So it's splitting by the white space. So it excludes the white space. Then it's collecting it. And it's actually specifying the type here. It's saying collected as a vector of string slices. We've seen this before. You could also leave this off, but it won't necessarily know what you want to collect it into. You might want to do capital S string, for example. So this is being explicit. And you'll see Rust Analyzer will let us know what's inferred. And you'll see that we'll have a separate video on how I set up my editor to use Rust Analyzer, but you'll see as soon as we open the code, you'll see those hints. And you've probably seen them if you've been following along. All right, the note is 2 times 2 is 4. Again, we're just splitting it, collecting it. So splitting it by the white space, collecting into a vector. And then we're calling construct note. Actually, we're calling can construct note, and we want to know if we can. In this case, we want it to return false since the magazine only contains one instance of the word 2, but the note requires 2 of them. What do we mean by that? 2 times 3 is not 4, right? It only contains one instance of the word 2, but our note requires 2 instances of 2. So that's why we can't construct it. All right. So this should return false. This one, however, should succeed. The magazine says, astronomer Amy Mainzer spent hours chatting with Leonardo DiCaprio for Netflix's Don't Look Up. Good movie. The note is Amy Mainzer chatting with Leonardo DiCaprio. And we confirm that. We see Amy Mainzer, hopefully I'm pronouncing that right, Mainzer, chatting with Leonardo DiCaprio. So this one should succeed. All right, so we have the basic idea. Let's jump in, and where do we start? As always, we're going to start with the tests. If you've been following along, you know we like to start with the tests. So what does that mean? I pull up the test, and I take a look at what my tests are testing. And we'll solve them one at a time, starting with the first one. So the first one just tests, test magazine has fewer words available than needed. So example is the first example they gave us. 2 times 3 is not 4. The note is 2 times 2 is 4. We split on the white space and we collect. And so we need to figure out if we can make the note. And this one should return false. So let's run our test just to show that it fails. There you go. You can see it failed. So we can see here that it failed. Let me make myself a little smaller. There we go. So there you can see that it failed. And so now what we'll do is we will try to make it work. So let's go to our source. Sorry, not target. And let's look. Here's the unimplemented function. So this is the function we're going to have to implement. And again, we want to use the Hashmaps entry API. So where should we start? Well, we're going to do test-driven development. And you've heard me say this many times. We're going to write our code until our test passes and then refactor our code. Why? Because we can lean on that test, right? The test is there. We know if it works or not. And we can lean on that test. Now, we could make this test pass by simply returning false. But it wouldn't make this test pass. But just to show you that, it's not always, accurate to just run test, and to show that why you would need multiple tests is if I just return false, we can see it works. So that's why one test just isn't enough. You need to test all the scenarios because it's not actually doing what we want it to do. So what we want it to do in this case is we need to check that for each of these words, right? Or actually for each of these words, 2 times 2 is 4. And remember, we need 2 2s. We want to see if we can make it with this list here. So how are we going to do that? Well, let's think about this is a classic algorithm problem, right? How do we do that? Well, they want us to use Hashmap. So Hashmap is a great use case for this. What we can do is we can create a Hashmap representing the word and the number of times the word occurs in the magazine. What do I mean by that? We can use the word as the key. So for each word, we can create a key in our Hashmap. And if we see the word again, so we create a Hashmap where the key is the word, and the value is how many times it appears. So we go through, we add 2 to the Hashmap and set it to 1 because we've seen it once. We add times to the Hashmap, so the key times value is 1. We add 3 to the Hashmap, key is 3, value is 1. Same thing for is, key is, value is 1. We add not, key is not, value is 1. We add 4, key is 4, value is 1. Now, when we go to actually check this list, what we'll do is we'll go over and we'll see, okay, 2, is 2 in that Hashmap? Okay, it is. And is there 1? Yes, great. The next time we get to 2, we'll have to see that that 1 has been exhausted. So we'll have to decrease it, right? So we're going to use the Hashmap as almost like a lookup table or a dictionary to say how many occurrences of each word are there. Make sense? So let's take a look at this entry API they want us to use. So if we go to the standard docs, and again, we're going to use the docs because the docs are fantastic. I'm going to zoom in so that you can actually see them. And we want to look at the entry API. That just, what they mean by the entry API is just the entry part. So what does entry do? It gets the given key's corresponding entry in the map for in-place manipulation. Cool. What does that mean in practice? We have a new Hashmap called letters. For each character in this, we're going to create a counter. Counter equals letters entry ch. So they first try to see, is there an entry in the Hashmap for that letter? If not, so if there isn't, insert 0. And then it actually lets us manipulate it. So we can use this. We can say, for our case, we can go over those words, right, in our vector. We can check, do we get an entry? If so, it gives us the entry. Otherwise, we'll insert a number 1, for example, and we'll create the entry, right? So let's see. So if we look at the entry API, which is actually this thing, we can see the options that we have. So we have or insert, so that's what we just saw. Map entry ponyland or insert 3, so it tries to get a value. If there's no value, we insert a value. Insert with, it gives you a function. Insert with key, so a lot of different options. I think what we can use is just this or insert. So let's give it a shot. Let's talk about the algorithm. So again, I like to kind of type out what I want to do first. That helps me remember. So we want to, for each word in magazine, right? Create a Hashmap with the word as the key and the number of times it occurs as the value. Do this. So basically my capital D. Do this by looping over the magazine vector. Creating the map / updating. There we go. The map as we go. So for this, we can do a few things. We can do a straight iteration for word in blah, blah, and create our map. But whenever I have a vector, and whenever I'm taking a vector and converting it to something else, so I'm actually taking magazine and converting it into a map, I like to use reduce. Reduce is a really nice functional way to convert something of one type into something of another type. However, if you remember from our book work, let me just pull it up over here. Reduce in Rust Reduce in Rust actually it reduces the list down to a single item of the same type. So we can't actually use that because we need to change types. What do I mean by that? Well, look, reduce takes a thing and a function and returns an option self item. So what do I mean by that? It reduces, you don't get to create an initial value. It basically just takes your item and reduces it down to a single value of the same type. What we actually need is the operation called fold. And again, we don't need this. We could just loop over, but this is how I prefer to do it when I'm converting stuff. So what fold does is fold works exactly like JavaScript's reduce or Python's reduce. It takes an initial value, which in our case will be an empty hash map, a function that is the reducer function. Basically, it takes the previous value and the next value, the previous value being the output of the first run of the loop, second run of the loop. And what we can do is we can go over that vector and create a hash map as we go. So I like fold for this. So I'm going to try to use fold for this. So let's see what that looks like. So we have magazine dot iter, because we want to iterate over it, dot fold, and we need to give it our initial value. So for our initial value, let's use a hash map. So what we can do is we can do hash map new, create a new hash map, and then we give it our function, our reducer function. So for now, what I'm going to do is I'm just going to say accumulated map, ACC map. We can also call it map so far or something. And then we'll call it current word, or current word, like cur word. And then as you can see, this is our, if we go to fold, this is our function here. This is what we're putting here. And so we have a multi-line function, so we'll just do this because we're going to probably need more than one line. Okay, and let's see what fold says. Fold says, folds every element into an accumulator by applying an operation. It takes two arguments, initial value and a closure with two arguments and accumulator, right? So let's see, what does this say? Add semicolon here. Oh, we need to tell it what the type of map we're dealing with. So the type of map we're dealing with is it's going to be a map, and we can actually tell it here. We could say that it's a hash map of type, instead of unknown, unknown, we can do string slice integer, because we're going to have an integer, right? So we could say accumulator map is of type, oh, let me go here. Where's my cursor? There it is. It's going to be hash map of type string slice and signed. So we want to sign 32 bits. So we're only going to have positives. So now this is saying it creates an empty hash map, but it says mismatch types. Expected unit type found struct hash map. That's because we're not returning anything here. It's inferring the return of our function here. We just haven't returned anything. So let's do this. Oh, and actually this will be string. Actually, I think it'll be that. All right, so let's just return something. Well, for now, let's just return ACC map. And let's see what's happening. So it says a hash map implemented with quadratic problem. No, that's not what we want. I want to see the error. Where's my error? There we go. Expected type, unit type, found hash map. So let's see. So we have our function, takes the current word, which is of type string. We have our fold. We have our hash map. So we're folding over that hash map. And what do we need to do? Here's where we're going to use that entry API. And so what we're going to do is we're going to use that entry API. And you can see here, let me zoom out a little bit so you can see more of the code. Maybe that's too small. Okay, I'll zoom back in. You know, I'll just move that. So you can see here, we're going to iterate over our magazine. We're using fold, so we have our new hash map. That's our initial value, just a new hash map. And in fact, we might even want to make it a mutable hash map because we're going to be altering it, right? So I'm sure once we start using it, it'll complain. But let's just say for now we have a hash map, and then we have our function. This is our function for what we're going to be doing. This value is what we're going to accumulate. This is the hash map we're building, and this is the current word that we're on in our iteration. So what do we want to do? we want to use that entry API, and we want to do this map.entry for the string, see if it exists. If it doesn't exist, we're going to insert 1, meaning, hey, we're here. Or we can insert 0 and increment. What do I mean by that? Let's go. So we can do a cmap.entry. What entry? We're going to get the current word. Or we're going to insert 0. And then right below, what we can do is we can just do, we can set that equal to something. So we could say let, and I forget if we need to make it mutable. Let's go back here. There was a good example. No, so it doesn't need to be mutable. It just lets us actually alter it in place. So let, we'll call it, let count equal, and then we'll do count plus equals 1, which means we're incrementing it by 1. So let's see what this says. So this says we have an error here. Mismatch types, expected struct hashmap string, found unit type. That's because we still haven't returned anything. So then what we'll do is we've altered our count, so we're just going to return the new map because it actually alters it in place. So our map should now have it updated. So if we do that, returning our map, and we can see here, cannot use plus equal because we have a mutable reference. So we need to actually, just like our example, dereference counter to get the actual value behind it. Because if we look at the value of count, you can see up top, count equals a mutable reference to an I32. So we just want to get the value, so we'll use the star. And what does this say? Cannot borrow accumulator map is mutable as not declared as mutable. This is what I talked about. So what we can do is we can just say, well, we have a mutable hash map. And since we can't use it here, we can say, I think we can do hashmap. We can define it out here. We could say, let mute magazine word map equal mute hashmap new, and then we can use that here. Magazine word map. Now it says cannot borrow as mutable as it is not declared as mutable. This one. Sorry, I was talking about the wrong one. So this we'll just have to make mutable. And there we go. So let's see, maybe I don't actually need to do this then. Let's go back here. Let's see if this actually works. Hashmap new. Cool. So there we go. We have our map. So now what we should have after this is we should have that map of word counts. Now, let's see if that actually works. Before we test anything further, let's see if that works. How can we do that? We're going to print this out. So we'll say magazine word map, and we'll print that out. Oh, right. We didn't set it yet. So let's do it here. Let's do let magazine word map equal, and we'll do it here. Magazine word map. And let's run our test. And so you'll see that by default, so our test passed because we just returned false, but you'll see that it also didn't print out. And that's because by default, the testing eats that message. We can give it a flag to tell it to print it out. I forget what that flag is, so let's look it up. Let's say cargo test output print statements. How to print during Rust tests. There it is, right? No capture. That means it won't capture and eat up our tests there. So we'll do the same thing, cargo test dash 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 no capture. And there's our word map. Check it out. Magazine word map. Times 1 is 1, 2, 1, not 1, 4, 1, 3, 1. Awesome. But we're not done. We just have the map. We still have to do the other part of the algorithm. right? So what was the other part of the algorithm? Well, it was looping over the note and making sure that we have enough words to cover it in our map. So here we'll write down what we're going to do there. Loop over the note and check if there is an entry for that word. If so, we're going to decrement the word count in the magazine and continue. If not, return false because we can't make it. So how are we going to iterate over that note? Well, we could just do a for word in note, right? Very straightforward. And what are we going to do? We're just going to use the entry API again. So we're going to do magazine word map dot entry, and we're going to grab the key. What is the key? The key is just our word, or insert, or we can do or default. So if it's not there, if it's not there, we should return false, right? So that's the key thing. So first what we can do is let's see what this entry just returns. So this entry returns an entry, and the entry has some properties about it. So if we go to the entry, we can see what does the entry have about it. Also, we get this in dark mode or something. There we go. Sweet. No. Where'd you go? Okay, that much better. So the entry we have or insert with key and modify, insert entry, or default, format. So let's see what we do. So here we can just default to 0, because if it's not there, it's the same as having no words, right? And then what we can do is we have that entry. So we want to store that. Let's say let match equal this. And then what we're going to do, match is a built-in word, so we can't do that. So we say let, we're really looking for the count of the words found. So we could say like instances found equal. Let's see what this default is here too. Why is it erroring? What does it say? Let's see. Supplied 1 argument, expected 0 arguments, found 1. Oh, or default. Okay. So or default defaults to the default value. So let's just instead do or insert, and we'll use 0 because we'll just set it to 0. Now here it's going to say that this isn't mutable, so we just simply need to make it mutable. Now we can actually mutate it. So now what we'll do is we have the instances found. So if it was able to find our word in the map, it will return it, right? If not, it will insert 0, which is good because now we can check, hey, what's the number? Is it greater than 0, right? Are there any? If so, move on. Then we have to decrement. So first let's do our check. So basically we have to do if instances found equals 0, well then we can just return false because we're done here. Otherwise, we simply need to decrement and move on. So what we can do is we can do magazine word map. We could just modify instances found, right? So we could do star instances found minus equals 1 because we found it, we use it, take 1 away. So you're cutting it out of the magazine essentially. Let's see what this says. Can't compare a mutable integer 32 with an integer. That's just because we had to get the value. There we go. Okay. Now, if we make it through this loop, right, it means we're done, right? If we make it through this loop, we found every word. So at the end, we could just return true. So let's run our test, see if our test still passes. Then we'll start enabling other tests, and then we'll go over the code again one more time. All right, so that test passed. Let's enable some more tests. This test tests that it returns true for good input. So if we can build the note, it should return true. So let's unignore that and run our test. Awesome, we're still good. This one tests that it returns false for bad input. What do we mean by bad input? Well, we can see this one is I've got a lovely bunch of coconuts, and this is I've got some coconuts. So obviously that won't work. So let's run our test. First we'll unignore it. And we're still good. Next, it's going to test for case sensitivity. This one has lowercase I've, right? This one's looking for uppercase I've, so it should not work here. So that's why if you look, it's expecting that you can't construct it here. And same thing here. It's the opposite case, and we're checking that we can't construct it. So let's go ahead and unignore that, run our test. And awesome, we're still good. Everything's passing. So now let's go ahead and unignore this one. Looks like I have a little delay. Hopefully it's not too bad. Let's see what's going on. Little delay action. Test. All right. We might have a little bit of delay, but that's okay. We can still proceed. Okay, yes, we have some skip frames. Let me see if I can fix this really quick. Let's take a look what's going on. Something running that shouldn't be. Let's quit that. Let's quit this. Let's quit this. Oh, this is open. That's why. I accidentally clicked Halo. Of course that's going to eat up my frames. Well, sorry about that delay. All right, so hopefully we're back on track. We'll go over stuff. Just Halo eats CPU. Who would have thought? Anyway, we're going to go ahead and undo that test. And let's undo this last test. This last test tested the magazine has one good word many times, but still can't construct, right? So it has that word a few times, but can't construct because those are missing. Great, so we passed all of our code. The only one we didn't pass is, this one we just had to save. Save, let's run it again. And we're great, everything passed. Now let's take a look. Let's take a look at what we did and see if we can refactor our code. So what did we do? We have our can construct note. And so the first thing we do is we construct that map, that hash map of key, which is the word, and the number of times it occurs. And so we do that using fold. What is fold? Basically equivalent to reduce in JavaScript or reduce in Python. And now there is a reduce in Rust, but reduce literally reduces in Rust, meaning it takes many things and returns one item. So if you have many integers, it returns one integer. Many options of integers, it returns one option integer. We want fold. We want to be able to take a vector and convert it to a hash map. Now we could have done this by simply iterating, but I like to use fold for this stuff because I'm into the functional programming thing. And you can see here basically what we do is we have our hash map. That's our initial value, just an empty hash map. Then we have our function, our reducer function, with our accumulator, which is a hash map, and then the current word that we're working with. And basically what we do is we use the entry API to pull out the current word. If it's not there, we insert it as 0, we increment it, and we move on. So the first time it's 1, second time if we find it, we get back the entry. It's already 1, it inserts 2, it makes it 2, we move on. Then we have that word map, and then from there, we simply loop over our note. We check if we have that value. So we do magazine entry and we see if it's there. If it's not there, we put 0, which basically means, hey, it's 0, we don't find it. And we do a check. If it's 0, return false, otherwise decrement it. So pretty straightforward here. Is there anything we can, because we have the test, this is our opportunity, we can refactor. Is there anything about this we want to refactor? Let's see. Usually I take a look at any kind of loops and conditionals as an option for refactoring. We can change this if to a match. That's a possibility. Is it much nicer than an if else? Not really. I don't think so. I think an if else works perfectly fine. We probably could, let's see, instances found equals 0. else minus plus minus 1. I think this is pretty fine. So what I mentioned by the match is we could do instead, we could do, of course, match on instances found. 0 would be return false, and then anything else would be found minus equal 1. So this is what it looks like with a match. Is it much better? I don't know. I don't really think so, but let's see. Does it work? Yep, so it still works, but yeah, I don't think it's much better. I think the if else is very readable, so I think if else makes sense. So we could just leave it like that. As for the iteration, I think the iteration is fine. I think we could also do, instead of a for word in note, we could use an iterator. So we could do note.iter, right? So we could do something like here where we're doing iter, and we could do, where is it? For each. Calls a closure on each element of iterator. But because we want that exit early, I think a for loop is perfect. We want to be able to exit early if we get false. So I'm pretty comfortable with this. I'm down to submit this, and we can check out how other folks have solved it. What do you think? Let's do it. So let's go ahead and let's put a comment here. I like to put comments. So here, the reason we decremented is the word was found and used, comma, so decrement the number of instances available for use by 1. Awesome. All right, so let's submit it. How do we submit it? Again, we can do exorcism submit, I believe. Here, let me search my history. Well, no. Exorcism submit. There it is. Magazine cutout. Awesome. And where are we at with time? We're doing good. Okay, I think we can get to the other one as well. All right, so it says our solution was submitted, so we simply can click here now. Hopefully we don't accidentally start Halo again and cause the stream to lag. Sorry about that again. All right, so we just submitted it, so I'm just gonna refresh this. It should, actually, if I just go back to here and refresh, we should see it. Let's see. We have our iteration. It passed. Awesome. So pretty good. Let's see how other folks did it. That's one of the coolest things about Exorcism. We can see community solutions and we can steal. Just kidding. Not steal. We can learn from, right? Come on. Which one of you looked at code on Stack Overflow and borrowed it? No, but we get ideas. That's the whole point, right? We're not trying to be the best. We're not trying to be the most clever. In fact, in some ways, I always favor readability. And you might be saying, Tom, you favor readability, but you used a fold, jerk. That's because it's functional. I like fold. I think it's readable. But yeah, we obviously could have just used a for loop. But I like fold. I think it works perfectly. And I like to convey the idea that fold is great for folding and changing something from one shape to another. I think it's the perfect use case. So that and reduce is great for summing a list of numbers, right? So let's look at the community solutions. I bet there's some real super clever ones. All right, so let's check out this Surfing Tom Hens. It's another Tom, but he surfs. All right, so it looks very similar to ours. I see a fold. I see a fold. I like it. I see 2 folds. Wow, 2 folds. Wow. Let's see what they're doing. 2 folds. So they're using fold here to create the new hash map. Same thing we did. Mute words, string. The reason theirs looks, so you may have said, hey, why does yours look so crazy in the editor? And that's what I was talking about. So I'm using Rust Analyze, which is inserting some type inferences. See this like colon string? That's not actually written, right? That's just, it's a light gray on my screen. It's not actually there. I did actually write this, but I don't even have to do this anymore because it knows. It's going to know the type. It's going to be able to infer the type. And you can see it's inferred. See that? So it looks more because it's showing me the types in line, which maybe is annoying, but it's nice. But if you look at my actual code, you don't see those. it would look more like this. So they're doing the same thing. So they're doing words entry, string, or insert. Oh, but check this out. They're doing the mutation on the same line. So that's interesting. I've never thought to do that. So they pull out words entry, and they just mutate it in line. So very cool. So we could definitely try that. We'll reduce our code by doing that. I like that. And then they create note words, which is a hash map as well. And so what they're doing here is they're doing the same thing. So they're creating 2 hash maps. Then they're iterating over note words and calling .all, which let's see what that does. Iter all. Oh, I'm at it already. Tests if every element of the iterator matches a predicate. All takes a closure that returns true or false. It applies this closure to each element of the iterator, and if they all return true, okay, so it checks, it's basically filter, but it's checking that all of them match the same criteria. Makes sense. I think we have something like that with Lodash. I don't think we have that in JavaScript, but we might. I know I can do it with Lodash. So, okay, so it's doing that. That's pretty sweet. Let's see what it does. What's the condition? Magazine words.get unwrap or 0 greater than or equal to count. So it just checks that for each word, it is equivalent to, or there is a count equivalent to or greater than in the other hash map. So I think ours is fine. I think we, in some, like speed wise, we're at the same, right? They loop over the list 3 times. So 3n. We do it only twice, right? Because we only do 1 loop, another loop. We don't create that intermittent hash map, which I think is fine. So I actually like ours. I think ours is readable and understandable. I think theirs is readable too. But what I do want to try is exactly what they had. So let's try this. We're going to reduce this to where they were doing it inline. I like that. Plus equals 1. And then what does it say here? Count. So they were able to do words.entry. Oh, we don't need to store a count. That's why. That's why. We just want to do ACC map. So they don't even, they're just doing it right in line. So you don't even need to set it to a variable. So we can do that same thing there. And we can actually do that same thing here. But we actually here we don't want to do it because we want to keep track of instances found so that we can compare. Right? So yeah, that's cool. I think that's a cool shorthand. Let's try it. Let's run our tests. And now we can submit a second iteration, which is really cool. So we'll submit a second iteration. Go back here, refresh. Pretty cool. We'll look at some more solutions and then we'll jump into the next exercise. So yeah, there's our new iteration. Everything passed. Let's look at some more community solutions, see if anyone else did it kind of similar to us. So here's something very similar to ours. Instead of a fold, they just also used a loop. I think this is super clean. In fact, in some ways I like this better actually. Now that I'm seeing it like this, yeah, the fold is cool, but this is super clean, right? Super readable. Awesome, love it. Really cool. This is why I love Exosystem. All right, so I'm happy with our solution. We could keep going and look at others. Just quickly see. I think kind of we all have the same kind of idea. Very cool. So what we'll do is we'll submit our solution. So we will mark it as complete. I'll share all my iterations so everyone can see them. I think that's a fun way to do it. And we'll go back to the next exercise. All right, so we'll do one more. Let's see what time it is, just see where we're at. And let's see if I'm lagging anymore. What do we got? Skipped frames 13 minutes ago. All right, so we got some frames skipped. Hopefully we're okay. You know what I can do here? Well, I hopefully can get rid of that, whatever that is. Yeah, I think we should be good. We should be good. We should be good. We might be overheating a little bit. Let's open this up. Give me 1 second. There we go. Cool. All right. So hopefully that clears things up. If it's bad quality, just let me know where it messed up and I can always fill in the blanks. All right. So next what we're going to do is exercises, syllabus, vector S stack. Okay. Reverse Poland notation calculator. I've seen RPM before. I'm familiar with these. So basically what we're going to try using here is use a vector to simulate a stack, putting stuff on, popping it off. So let's take a look. Yeah, I've done this one for JavaScript, pretty sure. But it'll be nice to see how it works in Rust. So we're going to create a reverse Poland notation calculator. It's a way of writing mathematical expressions that's different from what we're used to day to day, right? We're used to something like this, 2 plus 2. Instead, we're going to do it 2, 2 plus. So it's almost like, if you're familiar with like a Lisp syntax, you know how you give it sum and then you pass it the two values as a function? Kind of like that. You've probably seen something like this in functional programming. But here's another example. This is how we would have to write it, right? But it's harder to parse, right? You would need to know PEMDAS, right? Parentheses, exponent. So you would need to know that multiplication, division. You need to know the order of operations to make this work. Here, you can write it, and you actually don't need to know the order of operations. The way that you evaluate it is you take the first two numbers, apply the operation, take the next two numbers, apply the operation, and take whatever number's left and apply the last operation. So here's an example of how it works. Let's manually evaluate that complex expression as we learned in the introduction. Evaluating RPM requires a stack. This stack is used to hold, excuse me, need some water, numeric values that the operators operate on. We start our calculator with an empty stack and then evaluate each element one at a time. First, we encounter a 4, so we push it onto our freshly created stack. So stack, you think about it just like a stack. So you put 4. Next, we encounter 8, put that on the stack. Now we encounter a plus symbol. So we pop off the top two most values. So we pop off that 8, we pop off that 4, and we add them. We get 12. We then take 12 and put it back on the stack. So you can see here they put 12 back on the stack. Then we add 7, then we add 5. We counter minus, we pop off 5 and 7. We do the subtraction, 7 minus 5. And we get 2, we put that back on the stack. So it's 2 things at a time. 2, whenever you get an operation, you perform it on the last 2 and return. So our goal is to write a calculator to evaluate a list of inputs ordered by reverse Polish notation and return the final element in the stack. If there's not exactly one element in the stack at the end, return none. So if you don't have just one element at the end, if you have more than one, there's something wrong, so we return none. If there's an operator with too few operands, such as 2 plus, we need at least 2 operands, right? Then return none. You're given the following enum and stub function as a starting point. Okay, so we have an enum of the operation. That's going to help us. I like that. And then we have evaluate. All right, so what are we going to do? We're going to copy this here, go back to our terminal here, paste that. Huh. Weird. Didn't paste it at first. All right, so it's going to download that exercise, and then we'll pop it in. Awesome. RPM calculator is ready. Let's see if my code dot works now. Yeah, there it is. Okay. All right, let's close this other one out. Open this back up. All right. So let's take a look at our test because we kind of have an idea of what the code is. So our first test, okay, so this thing here, they just have a helper function for their tests. And the helper function basically just creates the array of inputs, I think. Yeah, it's going to take the string that you pass it, split it by white space, and create actual inputs. So they can write plus, but it'll actually send us the proper enumeration. Awesome. Why does code dot always break? Yeah, I know. You had this issue last time. I don't know. At least I know it has something to do with my Windows subsystem Linux. On your machine, no idea. Works on my machine. All right, so the first one is test empty input returns none. All right, let's run the test. We can make this one work, and this is why I love TDD. We're going to make this work. It's not actually going to do anything, but it passes the test. All right, so it failed. So let's go ahead and make it work. And we'll do one of these things where we'll pull it up over here. Beautiful, beautiful, beautiful. I'm just going to zoom out one level. That should be good, right? Hopefully. Nah, you're probably used to it at this level, right? We'll keep it there. Keep it there. It seems so big, though. All right, we'll keep it there. We're used to it. We're used to it. All right, so what are we going to do? If the test is test empty input, returns none. So if you get nothing, just return none. What will the empty input be? It'll end up being, because our input here is a vector, right, of calculator inputs, we just want to check if the length is 0. If it's 0, just return none. So let's try that. Again, we're going to solve these cases one at a time, and then eventually we'll refactor once all our tests pass. But as long as we solve all the cases one at a time, we're solving the test and our business logic matches. So Doze in the chat and I worked a little bit on some TDD stuff last week, and it's super cool because you can figure out what your business logic is, write your code. It's not always applicable though, right? If you're doing some stuff's really impossible to test. UI, for example, is so difficult to test before you code it. But for units like this, functions, perfect. So that's why I love exorcism. So, all right, so let's do a check. If inputs.len equals 0, return none. And you can see here, it expects an option. So it may be missing an else, right? So it's expecting an option, but there's only one type. What do we do if it doesn't equal 0? Right, so it needs to know, what do you want to do if it doesn't equal 0? For now, we'll just return, just for funsies, sum 0. So why are we doing sum 0? Because the output it expects is an option of a signed 32-bit integer. So we didn't get that part working yet, so for now we'll just return sum 0. And again, we don't need, get rid of this, get rid of this. The reason this is squiggling, it's saying, hey, you don't need parentheses. You only have one case. So we'll toss them. We can leave off our semicolons and these will return. And now we can run our test. Bam, we're good. We passed. But of course our thing does nothing, right? But it passed the first test. But so let's keep going. Let's add another test. Next is test simple value. What is a simple value? If all they give me is one value, it's saying here it should just return that value. If it just gives me an array with one value, and it's a value, it's an operand, not an operator, just return the operand. So let's do that. So let's uncomment it, save, see that it fails. Fails, great. Now let's make it work. So we have this case. We're good there. Let's cover the rest. So let's put our sum 0 there. So this is the same scenario. Our test will still fail for that one test. I just want to restructure. And so now we're going to do a check. Let's just do, let's go back here. Let's just add an else if. If the length is 1. And again, we're going to refactor this, don't worry. Else if inputs.len equals 1. And now we want to see what inputs, what it is, what the value is. Inputs 0. Well, let's do, okay, if it has length 1, let's match on it. So we'll do a match. Match on inputs 0. So we want to get the first value. If, and remember, it's a calculator input, so we can do it. We're dealing with these here. If we get value x, so if we get a number back, we're just going to return x. If we get anything else back, we're going to return none. Meaning if we get divide, multiply, subtract, or add, we're going to return none because, well, it's not a valid scenario. You can see here it's saying value cannot find tuple struct or tuple variant value in this scope. Oh, that's because we need to preface it with the, it's an enum. So we need to say explicitly calculator input : and then here it's just saying we need to return it, right? Expected an option of I32, but we return an I32. So we need to just use our option. And so there we go. So if length is 0, it's going to return none. And we don't need to have returns here because we just have 3 branches. It'll just evaluate this match. This match evaluates as whatever it evaluates as here. So if the length is 0, it returns none. If the length is 1, and that thing happens to be a value, return it. Otherwise, return none. And otherwise, return sum 0. So this, again, this isn't doing anything. But let's see. At least it'll test, hopefully pass our existing current test. Beautiful. All right, so that test passed. Next one. Test simple addition. So how does simple addition work? Well, get out of here. Don't start Halo. Swear. Okay, so the way simple addition works is it's going to give us 2 plus. We're going to get that as a vector. Don't worry. That's what their helper function's doing. So we're getting an operand, operator. and we should end up with sum 4. So it returns an option, so we should end up with 4 wrapped in a sum because it's an option. So let's do that. So that's like our other condition, right? So if length's not 1, so we're outside here, right? And so we're like, okay, if it's 1 and it's that, we can return this. Otherwise, we'll return this. Otherwise, we're now dealing with a bigger array. So let's loop over it. So let's do for entry, or let's say for item in inputs, right? And we want to use a stack. So let's create a stack. So let's say let mute. We'll call it RPN stack equal, and it's going to be a vector. And you can see here it's telling me that the vector type is unknown. I can tell it what it is. So I'm going to tell it it's a vector of signed 32-bit integers. It will be able to infer it once it sees how we're using it, but I'll just tell it. Hold on, what does this say? Cannot find type vector in the scope. Oh. Sorry, vec. It should be vec. All right, and so for item and inputs, so for each item, what we're gonna do is we're gonna do a match on it. If it's a value, we pop it onto the stack. If it's an operand, we try to pop off the stack, perform the operation, and move on. So we're gonna match on input. And again, we don't need the parentheses, so there's a single value. And what are we doing? If, again, if it's, we're gonna match on the type here. So if it's a value, X, right? We are going to pop that onto the stack. So we're gonna do RPN stack dot, or sorry, we're gonna push it on X, and we'll push X onto the stack. Now it's complaining because we haven't solved the other scenarios. There's still other types. So let's solve the other types. If it's anything else, meaning if it's any of the other operations, we need to pop two things off and perform the operation. So we can use a blanket statement to handle that, right? Or we can handle each one individually. We can do divide, multiply, subtract, add. So we could do that here in line, but I think we'll probably want to break it out into another function. But first, let's just, for now, for simplicity, say, if it's anything but that, we're going to do our popping. So let's pop our values off. So let's do let y equal, because again, it's a stack. So x, y, we're going to pop y off first. So y equals rpn stack dot pop. And again, because there might not be any values on our stack, this might fail. And so that's why pop returns an option. So we're going to need to check that this actually exists before we do anything with it. Let x equal rpn stack dot pop. So it's either going to be none or some value. And then we're going to want to perform an operation with those two. Which operation? Well, one of these. So what we could do is we could have an arm for each of these, but then we'll be duplicating our pop logic. So what I want to do instead is break that out into a function. So we'll create another function here. We won't make it public. We'll call it perform operation. It'll take the operation, which is going to be of type one of these, right? Calculator input. And in fact, we probably actually just want it to be one of these. So there might be a way to specify an enum that's just, you know, it's going to be one of these. It won't be a value. But anyway, for now, we'll just say it's going to be a calculator input. Let's make it simple. It's going to take an x, which is going to be an unsigned or signed 32-bit integer, and a y. Actually, it doesn't need to be signed, but maybe we're dealing with, I don't know. Let's just do I32s, because I think that's what we're expecting here anyway. All right, so it's going to take x and y and an operation, and we're going to need to perform that operation. So let me just move our tests out of the way here for now. Okay, so what is perform operation going to do? It's just going to do our math for us. That's all. So we're going to match on the operation. We can get rid of this. And if we just need to handle each of these. So let's first type out calculator input add. And then we need subtract. Oh, why is it doing that? Subtract, multiply, divide, and then if it's anything else, we have an issue, so we'll return none. So we're actually, this thing is actually going to return an option I32. Make sense? Okay, so here we're gonna do this. All right, so what is our scenario? So if we have add, all we need to do is we need to do x plus y. If we have subtract, x minus y. If we have multiply, x times y. And if we have divide, of course, x divided by y. This is saying something here. Mismatch types, expected enum, option 32, found type, integer 32. That's because it's expecting us to return an option 32. So all we need to do here is just wrap these in sum. All right, so now we have our perform operation. What does this say? Unresolved macro option. Okay, wait, hold on. I think I just need to... I think I just need my arrow, and I need to say option I32. There we go. So now we have a simple function that, given a calculator input, performs a function. If it doesn't get a correct operand or operator, it returns none. So here we can actually use that perform operation. So we have x and y, and we can say, and we can actually do our check for x and y here. Like we can check if it's none, or we can do the check here. It doesn't really matter. Maybe we do it here. I don't know, let's see. So first we'd want to do, yeah, I think actually let's do that here. Let's do that check here. So let's make this an option, because it could be none, right? Because it might pop off and be bad. So what we'll do here is we'll just do if x equals none or y equals none, return none. So then it won't perform that operation. And it's just telling me again, hey, JavaScript guy, get rid of your parentheses. Here it's saying that that it doesn't know at this point, still thinks it's an option. So what we can do is we can just change our logic here, put this whole thing in an if, which is basically going to say if x doesn't equal none and y doesn't equal none, then we can do this operation, which again, it's not going to make sense because it doesn't infer. It's not like TypeScript. So what we can do instead, which is kind of cool, is we can actually match on a tuple. So check this out. What do I mean by this? We need to tell this thing, hey, x and y are going to be, we're promising that they're going to match. So how do we do that? We can actually match on the tuple. So we have x, comma, y. And here we can make our match statements tuples that actually include x and y. So here's what I mean by that. Check this out. This now changes to so we have calculator input, comma, sum x, comma, sum y. And then we just copy those here. Paste that here. Paste that here. And we also need a closing parenthesis. So check out what we did here. It's a little bit confusing, but what we did is we actually matched on all three. And so we're saying if we have calculator input add and we have some x and we have some y, we have subtract, we have some x, we have some y, do this math. Otherwise, if it doesn't match any of these, meaning it might not match if the operand's wrong, it might not, or the operator's wrong, it might not match if one of these is none, we can't perform any operation, just return none. So we're actually handling that scenario pretty gracefully with a match on a tuple. So I think that's pretty cool. So let's do our thing here. Now we can actually just pass these to perform operation and it will return the appropriate thing. Perform operation, we're passing it the input in this case, which is the operation input, and X and Y. And so now what this is saying is expected enum option I32 found unit type. And that's because we need to actually return something here, right? So here we can return at the end. So, okay, so what this is going to do is it's going to perform our operation, but we need to push the value, the result of this operation, back onto the stack. So we'll do rpn stack dot push the result of this. So let's mark what the result of this is. Before we do that, though, we probably want to check that the result is not none. If it's none, we can just exit, right? We have an error. So what we can do is we can say let result equal, and then we can just do if result equals none, return none. Otherwise, we'll do rpn stack dot push result. And then at the end, so now let's go over what we're doing again. Let me just return something so that it stops complaining. Okay, so we're matching on input. It's just telling me that a local name that's pretty close. So let's change it. We'll say, sorry, we want to match on item anyway. Item. And so here we want to be item. Okay, so here we're matching on item, which is calculator input. And here we need to change this to calculator input value. So if we have a value, we're just going to push it onto the stack. And here it says expected in 32, but found a reference. So we can just push the value. If we don't have a value, if we have some operator, what up, Rigolo app? We are working through exorcism on Rust. We're going through an exercise where we're creating a reverse Poland notation stack calculator. So check it out. It'll be up on YouTube. You can rewind and catch up. But basically, we're going through exorcism, RPN calculator. I'll paste it here in the chat. But you might be locked out of it because it's further along in the course. All right, so thank you for joining Rigolo app. Appreciate seeing you here. And feel free to ask questions as we go. Same thing for everybody in the chat. All right, so calculator input value, we're pushing it onto the stack. If we have an operator, meaning any other situation, we're going to try to pop X and Y. We're going to call perform operation. Okay, it's expecting enum calculator input. We just need to change that here. We're golden. So if we have any operator, we need to simply perform the operation. We pass the operator in X and Y. We've delegated the handling of none, values being none here. So, you know, if it doesn't match, if we don't have a value, it just returns none. And then down here, we check if result is none, just return none. Otherwise, we're going to push the result onto the stack. And you can see here we have expected type I32, but found enum option I32. So here we can just say, you know, unwrap it because it's an option and we've already done a null check. Or what we can do even better is if result is not none, push it. Then we don't need to do our explicit check. So we can say result or rpn stack dot push result dot unwrap. Because we've explicitly already checked that it's not none, so we can use it. We could also have done that up here. We could have declared X and Y and unwrapped them, but I thought it was cool to match on the tuple. So now we push it onto the stack. Of course, if we can push it onto the stack, right, if we end up with none, what's going to happen is if result is none, we can just not push it back onto the stack. That'll leave us with an empty stack. Or we can return none because we know we have an issue. We can early exit. So let's try that. Let's return none. It's basically saying, hey, something got messed up. Let's just return none. and that's going to be inside our else condition. And then at the end, what we want to do is we want to return the value that's on the stack. Awesome. Rigolo Apps, been watching since the Rustlang book. So glad to have you here. Yeah, we started picking up after the book. We started going through exorcisms. So right now we're on this exercise. We're learning about vectors as stacks. So thank you for watching. Really appreciate that. So yeah, if you want to catch up, if you missed the beginning, it'll be up on YouTube. But basically we covered this exercise, and you'll be able to see my exorcism. It's all public. So you can actually go into exorcism and look for me. It's just my name, Tom McGurl. And you can see the exercise we've done and the solutions and the iterations. So it's really cool. So thank you for watching. So we have calculator item. Yeah, I think I remember seeing you in the chat earlier too at some point. Maybe in one of the earlier videos. It's been so long for me. So yeah, so basically what we'll do at the end. So we've iterated through. We haven't returned none, right? So we have a stack with values. So we need to check how many values do we have. Remember, there's an error if we have more than one value. So let's just do a quick check. If rpn stack dot length is 1, if we're good, right? We're just going to return rpn stack 0, the first item. Otherwise, we're going to return none because there's an error. Also check this out. Expected option I32 found I32. So we'll just return some. We could also be pushing options. Like we could also just push, right, X onto the stack. The problem is that our RPN stack is a vector of I32s, but we can simplify this by just saying, okay, our stack is a vector of option I32s. And so it allows to push X. It's expecting a reference. That's why. Okay. So we could say that. We could do that too. We could say, okay, expects a reference to I32. Yeah, I think it makes more logical sense to just say. Well, actually, why is. Okay, value is I32. So we pull out the value. Yeah, no, I think this is fine. I think it's okay to just say, we'll return some, then the value there. We can get rid of this. And then otherwise return none, right? We could just do this, right? Also, you could just do this. But we'll refactor after. Let's see if it works first. All right, so we have our code. Let's test it, and then we'll go over it. So let's pull up our tests. I am just going to make it a little smaller while I'm testing just so we can see everything. Hope that doesn't bother anybody. Awesome. All right, so let's uncomment some of these tests. So test simple addition, we tried that already. We're going to test simple subtraction. Oh no, did we test addition? Let's see, does addition work? Awesome. So simple addition worked. That's great. Simple subtraction, multiplication. I'm just going to undo all these because I'm pretty sure they should all work because they're all similar code paths. We'll try complex after. Let's just make sure these work. And if they don't, we'll delete them one at a time and go over. Awesome. So far so good. Everything's working. Let's try getting the complex operation. Hell yeah. Complex operation worked as well. Now let's give a shot to the too few operands. Test too few operands. Yes. Should return none. Let's clear this out. Cargo test. Awesome. That worked. I think, do we skip one up here that we should? Okay. All right. So test too many operands. Test 0 operands. Let's just uncomment these all because I think we're basically done. Let's see. Let's clear it out. Awesome, they all pass. Hell yeah. So we did it. Let's go over what we did. So we have all our tests, they all work. So let's go over it, see if we can simplify it and refactor. Now that we have our tests, TDD, baby, we can refactor, right? That's the best part. So let's look at this first. Perform operation. Perform operation is a basic function. It's not public, so it's private to our library here. And it takes in the calculator input, which is either an operand, it's either add, subtract, multiply, or divide, because it references as enum, or it's a value. If it's a value, we can't perform an operation. It's not an operation. So we return none because there's an issue. We also take in an option X and an option Y. That's because X and Y are coming right off the stack. We're just passing them right to this. We could have done our checks in our other function, but we've delegated that check to here. You may say, that's a little bit out of the context of what the function is because it's just called perform operation. It should take the operation and the values. But we delegated it out here because it's a little bit cleaner and it lets us focus on our code. And also, it's going to return an option I32, so I think it's okay that it takes an optional X and Y. What do? We match on the tuple. So we're matching on all three values. If we have an operator and we actually have a value for X and Y, we can perform the operation. Otherwise, return none. So it handles a lot of that error handling without us having if statements, which I really like. Okay, that's how that function works. Now here, what do? We might be able to simplify this a bit, particularly around this area. So first we check if the length is 0. If it's 0, we can't do anything. So we just return none. I don't think we need that check because if it's 0, we won't iterate, right? And so therefore it will do a check here. If it's 1, it won't be, and it'll be none. So let's see if we can just first remove this 0 check. I don't think we need it anymore. And again, we have our tests. So how can we tell if it's okay to remove it? Just run our tests. And great, our test still passed. So we didn't actually need that check because what'll happen is it won't iterate. It'll go here, do this check, and do this. Now, do we need this check? Because we're already checking down here if the stack is length 1, but I think it's actually valuable. But let's find out. Basically, what it's doing is it checks if the input length equals 1 and the input at index 0 is just a value, just return it. Now, what happens if we delegate this to our iterator and we don't do this check? Well, when it gets here, it'll have one input. It'll be a value, right? So it'll go to this line here. It'll push it onto the stack. It'll run out of things on the stack. It'll go here. It'll see that it's length 1, and it'll return it. So I don't think we actually even need this anymore. So let's try getting rid of it. And again, we can find out by just running our tests. And look at that. We don't need that anymore. So you can see how TDD is actually helping us refactor our code. We just got rid of a bunch of dead code that we didn't need. And you might say, well, why did we write it to begin with? Well, we were getting the test to pass. So we actually wrote these checks, we got all our tests to pass, and then we refactored. Yeah, we could have jumped right into writing the iterator, but I don't think we would have been that into the logic. We actually, in this case, solved the business logic first, and then we refactored. This is why I love TDD. Again, I'm like a broken record, but it is great. If you can do it, if there's a way where it fits in your workflow, it's so powerful. Great, so look, we've already reduced our code a bunch. Just to reiterate, here's what we got rid of. We got rid of this whole forward section here, which is awesome. Okay, what else can we get rid of? So in this case, we're iterating. We have our vector. We match on item. If it's a value, we push it onto the stack. Otherwise, we pop off the stack, and then we call perform operation, delegating to that. We get back a result. If it doesn't equal none, we push onto the stack. Otherwise, we return none. Now, we can get rid of this intermediate result. We don't actually need it. We could refactor by doing this. We could take this bit here, right? Put it there. But we actually do need result because we unwrap it here. So sorry, we can't do that because we need to reference it here. So this part, can we simplify this at all? Well, we could just have an if that returns right after this. But I think this is pretty good. I don't think we need to refactor anything here. We could match on result. And so if result doesn't equal none, we push, otherwise we return none. But again, an if else versus a match, that's 2 lines. I'm going with the if else because it's more readable. And then what about down here? Can we do anything down here? Well, no, I don't think so. I think if it's length 1, we return it. We're doing that check explicitly. Otherwise, return none. So yeah, I don't think, I mean, we could simplify this part, right? Like we could outsource this chunk here, but I think this is pretty good. So what I'm going to do, since we're getting close to the 10:30 mark. Let's go ahead and submit this and see how other folks have solved this. So we submit it. We pop back over to Chrome here. We refresh. And this is really fun. This is a cool one. I mean, this is awesome. I know it's like not necessarily something you'd code for work, but it just shows like, I mean, first of all, it shows like how cool it is to work with. I think the option type is fantastic. Obviously, vectors as a stack is something I'm familiar with being an engineer and using other languages. But if you're not, it's cool to see how you can use a stack to do stuff like this. And there's a lot of applications for a stack. It is a very common tool. So pretty cool to see. All right, so we passed. Now let's check out how other folks did it. This is kind of the best part, right? All right, let's check out. Oh, we checked out Surfing Tom's thing last time, but I think there's, so it doesn't fully solve the latest version of the exercise. So let's go over to this one, which does solve it. All right, so this looks really similar already to ours. So they have an evaluate, which takes the inputs. So they didn't actually use a helper function that the perform that we did. They did it right here in line, which is also totally cool. Let's see what they did. So they do that check. They do that check initially if there's nothing at 0. We didn't need to do that because, again, it's not going to iterate, so it's not like you're wasting code. It won't iterate, and so I think we were fine removing that upfront check. It doesn't actually save much time. It might save time if you consider the time spent allocating this vector, which is valid, right? It takes time to do that. But yeah, I don't think it had much of an impact for us to exit early. I think we're okay here. What else? For inputs, that's what we're doing. We just call it item instead of input. If it's a value, they push it onto the stack. So we did that. If it's anything else, so here we go. If it's any of the other operations, if the stack if the stack is less than 2, they return none. So they do a check right here saying, hey, are there enough values? If not, return none. Otherwise, pop them and unwrap them. So we talked about that, popping and unwrapping instead of delegating that to the perform operation function. And then they perform the operation right here with another match statement. I love this. This is super readable. Very cool. I think maybe this gets a little bit complicated, but I like how I broke it up. But we basically the same kind of function. And at the end, again, just to check to see if it's not 1. So they use stack.pop. That's clever. I like that. And also, if you look, their stack is a vector of integer 32. And they use stack.pop because it's an option. It returns an option. It returns a sum. So they didn't need to wrap it in sum. So pretty clever. I like that. They don't have to explicitly say sum because pop by default returns an option. I'm actually I think that's I'm gonna borrow that. But I like that. I like using stack.pop because you're getting a sense of the stack. So I'm gonna actually use that too. I'm gonna do rpn stack.pop. And so if we run our tests, we're still good. And we can submit a second iteration. So yeah, that was really cool. Let's see what other folks did. Inside out clubs. So they have the same thing here. So they have binary operations. So similar to ours, where they're taking a vector, they're popping, and then, okay, this is pop x and y off the stack, returning function x and y. So yeah, so they pop x and y off the stack, and they return a function. Okay, a function of x and y. So they do, where does function come into play? F. Okay, so F is the actual function. So they take the operation and they pop it off the stack and they perform that operation. Pretty cool. Same thing for the, okay, they're doing something different. So for inputs, they're trying fold, and their input, this is cool. So their input is the vector. So they're also using fold here. Their input is that vector. This is cool. We used fold last time in the previous exercise, so it's cool to see it used here. And they have a mutable stack, and they're doing the same match. They're performing the operation right here by using binary operation, which takes the operation. So very similar to what we did, where we took the items, except they're handling the stack popping inside binary operation. And then they push that value. They're mapping over that, right? The result of that, pushing that onto the stack. And then stack. So this is really cool. This is very functional. I like this a lot. This is super cool. A little less readable, I think. Right? Like I'm having a little trouble parsing it, but like, let's see. So we match, it gets a value. It's either sum x or it's the operation. It maps over that, because how can it map over that? Let's see, why could it map over that? Okay. Sorry, the fold ends, where does the fold end? Down here. Yeah, so what is it mapping over? It's mapping over the match. The match returns stack. Yeah, I'm a little confused what it's mapping over. Stack.push x. Stack. Yeah, it's a little confusing. I'm confused what it's mapping over. It looks like it's mapping over the match, but match evaluates to a single thing, so that's confusing to me. Oh, interesting. I'm not as big of a fan of that one, even though it's pretty clever, because it's a little less readable. I'm having a little trouble parsing it. This is what we originally were going to do, remember? But we said there would be a lot of duplicate code. This is what we were talking about. But still, readable, right? So gets the job done. It's readable, right? It passes the test. It's just as fast. So awesome. So yeah, that's pretty much where we're going to end it today. I'm going to submit the solution. Let's go to overview. Mark is complete. Share all the iterations, and we're done. Awesome. So that was really fun. So what did we do today? We did vector and stack. So we've now completed our types, right? Our different exercise journeys and through the syllabus. And now we can go deeper on some of the other options like structs and enums. So we'll continue. We'll just go deeper, do more exercises. And hey, aside from the syllabus, there's still tons and tons of exercises we haven't gotten to. And you can see it here. On our overview, we've only done 10.7% of the exercises, so we have a long way to go. We've done a lot of the syllabus, but we still have tons to go. So I'm super excited. We can see how far we've come, completed all these 11 exercises. We did a pretty good job, I think, on all of them. So yeah, again, if you missed this or you joined late and you wanted to catch up, it's all going to be up on YouTube. This should be up tomorrow. So today is Tuesday the 1st. This will be up March 2nd. Tomorrow, this will be up by Wednesday in HD. So check it out. We have part 1, 2, and 3. We went through exercises. Again, today we covered vectors, stack, and entry API. Next time we'll go deeper on enums or structs. We'll kind of figure it out, or maybe we'll pick a random exercise. But yeah, leave some comments in the chat. Let me know how you've been enjoying this. A lot of you post some cool ideas for other content we could be doing, other apps we could be creating. Definitely coming up next, I'll be showing people about my color scheme. I've gotten a lot of questions about that, and we've had Gray Jack, who sometimes joins us in the chat, actually created this color theme. But also we'll talk about Rust Analyzer, how to get that all set up. I've had some talks with folks who are curious how I got VS Code and Ubuntu set up on my Windows machine in my dev environment. I've always been a Mac dev environment person, but I recently set this up so I could use my powerful PC to stream, which you saw hiccup when Halo kicked off. But yeah, I'll do some stuff on that. But definitely some more Rust stuff. We'll be continuing exorcism next week, Tuesday, 9 to 11 p.m. So yeah, thanks everybody for stopping by. Again, you got to do it. Don't forget, check out the YouTube. We got the videos. Follow on Twitter for when I go live updates. And follow me on Exorcism now. You can follow me. Tom McGrow. Search it. You can see where we're at. So that's it for tonight, everybody. Thank you so much. I've been having so much fun. I'm glad I'm back at it doing Rust. I'm really getting a feel for things. It's super cool. I love doing the TDD. You've heard me talk about it many times. But yeah, appreciate you joining. Doze Boy, thank you for hanging out. We'll pop over, do some code stuff together. But yeah, everyone have a great night, and see you next week.